All right, this video is going to go over notes 9.3a. This is just some more rationals, although these are going to be a little more challenging. So let's go ahead and get started. If you remember the last couple ones we did, it was always like this or something with like y equals, sorry. But there was never an x on the top. So that meant we really only had to focus on like our vertical asymptote at +5 and our shift for our horizontal asymptote. Well, that's no longer the case. So sometimes there's going to be rationals with x's on top and on bottom. When this happens, it changes how you find your horizontal asymptote. So the vertical asymptote will still be the same. You just look at the bottom and you set this guy equal to 0 and you solve it. So like add 1, you get x equals 1. That's still my VA, my vertical asymptote. There's still going to be a boundary right here at 1 that my function can't cross. But now to find the horizontal asymptote, you have to look at the lead coefficients of the x's. So like this one's going to be 2x over 1x. And these x's are going to cancel each other, and you're going to get 2 over 1, 2. This is your horizontal asymptote. So like, look at this one over here. There's an x on top and bottom. So for horizontal asymptote, I look at lead coefficient over lead coefficient. 1 over 1 would be y equals 1. So that's all I'm saying. That's the difference here. All right, so that's how you get your HA and your VA. Now there's going to be a little bit more information that you're going to need. You're going to need to find the X and the Y-intercepts as well. They help you draw the graph. So to find your X-intercept, you take the numerator, 2x plus 1, and you set it equal to 0, and you solve. And that's your X-intercept, -1/2. So it'd be like -1/2 comma 0. Like here. Oops, that's positive. Like here. All right, so to get X-intercepts, you set the numerator equal to 0. So like for this one over here, it would be like x plus 4 equals to 0. Subtract 4. I know I have an X-intercept at -4 comma 0. That's all I was trying to say. All right, and then for Y-intercept, you set x equal to 0 and plug it in and solve it. So like it would look like this. Y equals 2 times 0 plus 1 over 0 minus 1. So that's going to be 2 times 0 is 0, plus 1 is 1, over 0 minus 1 is -1. So this all turns into -1. So my Y-intercept here is 0 comma -1, right here. So like looking at this one again, you just simply set x equals to 0 and solve it. So it'd be like 0 plus 4 over 0 minus 2, which is 4 over -2, which is -2. That would be my Y-intercept. And that really goes for any function. You set x equal to 0 and solve, and that'll give you your Y-intercept for really any function. So once you have that, you're going to have to use these dots to help you draw your lines. So like I'm looking at these 2 dots. I'm going to have to connect them, all right? They're going to have to touch. They're part of my function. And then on a VA, on this vertical line, you have to go vertical. You can't cut through. You can't do something like that. So you go vertical. This guy would have to be going down. And so it would look like this. And then for the other section of line over here, there's a couple pieces of information that could give it to you. I know it's going to be like this. And the reason I know it's going to be like that is because on the bottom, this vertical asymptote, if you remember from the last lesson, if they're squared, the arrows are together. But if it's a degree 1, like this x minus 1 is degree 1, then your arrows are oppo on either side of this asymptote. Hope that made sense. Also, I knew it was there because there's no x-intercepts here. So there's no way I could have come up and cut through or something. It would have created an x-intercept that does not exist. So it would look something like this. So the domain of this line, there's two pieces being broken up by this vertical asymptote. So I've got a piece to the left, and that piece runs from negative infinity to the VA at 1. And then the piece on the right runs from the VA at 1 to positive infinity. And I would be done with this problem. Let's look at number 2. Okay, if I was approaching this problem, the very first thing I go get is my VA. It's here. It's at negative 1. The next thing I would go get is my HA. Remember, when there's an X on top and bottom, you have to look at the lead coefficients. So like on bottom, it's 1X. So you get 3 over 1, which is 3. So I've got my VA, I've got my HA. Now I'd probably go get my X-intercept. You get your X-intercept by taking the numerator and setting it equal to 0 and solving. So like add 2, divide by 3. I got an X-intercept of 2/3 comma 0, which is here. Okay, and then lastly, I'd go get my Y-intercept. And you get your Y-intercept by setting X equal to 0 and solving it. So you would get 0 minus 2, which is negative 2, over 0 plus 1, which is 1. So I got negative 2. So my Y-intercept is 0 comma negative 2 here. Okay, and once I've done that, I'm ready to draw my line. I'm going to connect these two dots first. And so on a VA, you have to go vertical, so it would start going down right there. And then you go level off on your HA. And this vertical asymptote at negative 1 was degree 1, meaning your arrows are going to be oppo. So if I have one down here, I'm going to have one up here. And then just go level out on your HA. And so that's what it would look like. I would have also known that this section had to be there because there's no x-intercepts here. So once I have the graph drawn, I go for domain. I have two pieces. This piece on the left here runs from negative infinity until the VA at negative 1. And then the piece on the right here runs from the VA at negative 1 to positive infinity. Okay, moving right along. Let's just restart this problem. If I was approaching this problem, the very first thing I would do is I would get my VA. It's here. It's at x equals 2. The next thing I would do is I would get my HA. This is a x over x. So 1 over 1 is 1. So y equals 1 is my HA. The next thing I would do is I'd probably go get my x-intercept. You get it from here, setting the top equal to 0 and solving. So minus 4, you get x equals negative 4. So I have an x-intercept at negative 4 comma 0 here. The next thing I would do is I would go get my y-intercept. You get it from plugging in 0 for x. So you would get plus 4 over negative 2, which is negative 2. So my y-intercept is at 0 comma negative 2 here. And if I was drawing this line, I would connect these two dots first. On a VA, you have to go vertical with it. So it would be going down here. And then you level off at an HA. These arrows are going to be oppo because the vertical asymptote here at 2 was to degree 1. So that means I know my arrow has to be here. I also know it has to be there because it cannot be here, because then to level out, I would have to create an X-intercept that does not exist. So I know my arrow would have had to be up here, and then I just kind of curve and level out on that HA. So my domain, I've got a piece running from negative infinity to the VA at 2, and then from 2 to infinity. All right, number 4. If I looked at this problem, the very first thing I'd realize is my VA is just at x equals 0. So it's here. All right, and then I would go get my HA, which is from coefficients, because it's x over x. So it's really like 2 over 1. So it's at y equals 2. Okay. The next thing I would probably go get is my X-intercept by taking the top and setting it equal to 0 and solving. So subtract 5, divide by 2. So I got negative 5 halves, aka negative 2.5, but I'll just leave it as a fraction. So that's like here. Okay, and then I would probably go get my Y-intercept next. So on this one, when you go look for this Y-intercept, you'd be plugging in 0 for x, right? So you get 0 plus 5, which is 5, over 0. Anything divided by 0 is an undefined. So there is no Y-intercept, which makes sense if you think about it, because I have a vertical asymptote there. I can't touch that vertical asymptote. So there's no Y-intercept. So I really only have one dot to draw this thing from. That's okay, one dot's all I need. It would have to be going down like this and over like this. It has to go vertical on the vertical asymptote. It would not have been like this. Let me show you. It wouldn't have been like this because I have to level out here on this HA. So it couldn't have done that. And it's not going to come back up and level out, because then it's going to create another X-intercept that doesn't exist. So that's how I knew it had to be like this. All right, and then this bottom is degree 1. So that means these arrows are going to be oppo from each other. So I know that this arrow has to be here like this, which makes sense because I couldn't have come up like this. It would have created an X-intercept that didn't exist. So the second piece of this line just looks something like that. So the domain, the left side goes from negative infinity to the vertical asymptote of 0. The right side goes from the vertical asymptote of 0 to positive infinity. So that's that lesson. Now I threw in one more of these problems just to kind of refresh your memory. So let's knock this one out. If I was approaching this problem, the first thing I would get is my vertical asymptote at x equals negative 4. So that's here. Okay, the next thing I would do is I'd go get my horizontal asymptote. This one's not x over x. So you get your horizontal asymptote from this shift at the end. So y equals negative 1 is my horizontal asymptote. In terms of the exact location of the X-intercept, we don't care that much. It's not like one of these where you're really needing the X-intercept to draw. But it would be beneficial, but I'm not going to go get it. Okay, and then now this is a negative lead coefficient. So instead of, if you remember right, positive over x squared and negative over x squared, you should have memorized what these parent functions look like. So positive lead coefficient over x squared, these arrows went up and up, these arrows. Negative over x squared, they went down and down like this. So this is a negative over x squared. So I know that my arrows are going to have to go down and down. And then you just go level off at these on the HA. So the domain of this, I have a piece going from negative infinity to the VA at -4. And then from -4 to positive infinity. And then the end behavior as x goes either way, plus or minus infinity. That means if I go left or if I go right, my y values are leveling off at the horizontal asymptote of -1. So that's how you would have done that problem. All right, so that's some slightly more advanced rational problems and how to graph them. Hope this video helped.